Hi, and today we'll go over how you can basically if you use SyncThing. If you do, you know what it is. It's basically a syncing tool for your files to sync them to your like NAS or something, to I don't know, some kind of, it's a server basically that like syncs all the files asynchronously. So basically, what is the issue with SyncThing? Of course, if you do a boot, I want SyncThing to be running on both operating systems at the same time. But that is of course possible if you have separate drives, but I do have shared drive, which I share between Windows and Linux. And what the issue is here is basically database and config files that SyncThing makes. That's the issue. You need to have unified files between two operating systems, because otherwise in one operating system you will, for example, create a file, then you will switch to another, basically that file will sync, and then you will switch to another like operating system, Linux for example. Then what system will do, it will see, okay, I just synced that file, but how is it possible that the same file is also on that drive already? Because I don't know, is that same drive or not? He doesn't know that's the same drive basically, just mounted in both operating systems. NTFS drive, NTFS you can mount in Linux and Windows, no problems. We'll also show how you can mount it, what are the caveats, what are the catches. Now, first of all, what do we need to do to mitigate that is run SyncThing with specified paths for the configuration and data folders. Data is where the SyncThing's internal database resides, and configuration is of course where his internal configuration resides. Of course, they need to save that somewhere, right? If you close it and or open it. Now, how you can do that is basically very simple. First of all, on Linux, you create a service. You can open that. This is an example of a service. What's important here is data and config. You need to specify that. You need to put that somewhere in a folder. Also, what is important here, you need to specify working directory, because every absolute path will mess things up. Basically, we need relative paths. That's why we need relative paths is because Windows and Linux don't have same folder structure or directory structure or whatever, and we need different kind of a solution. We can't just specify same thing differently. How do you do that? We can't. We need absolute paths. Now, SyncThing won't whine about if you do ./ I don't know. For example, in mine is called synced files. Basically, I set that as a working directory from where vsync is, SyncThing is launched, and then here is my synced files folder where I have my data, and we just need to do / synced files because we are already in that folder. You do the same on Windows. You specify different working directory path. You go to a different path from where you launch SyncThing, and From there, the path is the same. It's relative, right? It's not absolute. So that's why both systems will have, and forward and backslashes doesn't matter because SyncThing like internally makes them right. So you can do probably config, I mean, how do you think? Config probably needs to save them in one manner, in one manner only, so it's not an issue if you have forward slashes and back. Probably you can do backslashes in Linux also in SyncThing, and it will fix itself. Like, this is not an issue. So yeah, we need to data and config file, we need to specify that and set working directory. And what is also advised is have SyncThing binaries, both the same versions for Windows and Linux. Now, if that's, yeah, that's probably very important, because like if they switch like some kind of internal, if previously they switched the whole database, so if they switch database again, have two different versions, it will be fighting. Like one will be rebuilding most likely the new database, and one will be again trying to rebuild old database, or maybe old database will be removed in a come on, you don't know what will happen. Like, it's not like they have their it's not like one of the common scenarios, let me say it like that, to run SyncThing on two operating systems with same config and data, with same database. Like, it's not. And on Windows, for example, if we go scripts, edit PowerShell script, and you can see here we set location. Of course, as I said, it's relative, so we need to set location. We set data config again, the same ones we set on Linux. Of course, it's different path because it's different file structure. So this is basically it, what we need to do. Now, mounting drives on Linux, we can show you that very quickly. We can see basically these are our unique drive, unique identifiers. Don't change them. They don't usually change if you don't do anything stupid. But I mean, of course they don't change, otherwise your operating system wouldn't work. Okay, here is our mount path. That's where drive is mounted in a file structure. Of course, Windows also supports mounts, but usually no one mounts drives in Windows. They are like by default C, D, E, F. But I know Windows also supports that mounting, but it's probably janky and I don't know. No one uses that. Then we use kernel driver, not NTFS, what is called 3G. We use NTFS 3, which is kernel driver. No, we supposedly faster. There is also newer driver to replace NTFS 3 in development. Doesn't matter. NTFS 3 also has basic fixing of NTFS and NTFS drive. It doesn't have thorough fixing. No, won't go into details, don't even know the details. But I asked the intelligence. So here we have now defaults. These are options that are kinda important. Now let's go to them. Defaults, kinda set defaults like read, write. Usually user ID and group ID are set to the first user, which is not root. And then user, it's called file mask, directory mask, and this is, what is this? Now, umask, if I understand correctly, is basically kind of redundant in my case, because I have set file mask and directory mask. But I don't know, I think umask means like it sets both or something, if I'm correct, maybe. I don't know. Now how these masks, whatever, work, like, of course, this is file mask and this is directory mask. This is for files and this is for directories. Now fmask, basically, of course, folders, directory. How does it work is, it basically, for file mask, it subtracts the numbers from 0666. And why 666? Because if you did chamot sometimes, you know, 666 is basically not having execute. And because they go backwards, like, you know, 4, 2, 1, read, write, execute. So you see, it's 6, is subtracted 1, so no execute. This is because of probably most likely safety. And folders or directories, as on Linux call them, they have default 777, because every directory needs to be execute. It can't be not execute on Unix, Linux type systems. Now, as we see, we leave file mask as read write, and we subtract 2, so we only have read permissions for the groups and others. But for owner, we basically have everything. Directory mask, subtract 2. We basically have no write permission. So for groups and others. For our user, we have read, write, execute. So this is an example. Now we have also here UID and GID. These are user ID and group ID. Basically, usually this is your first ID. If you don't have multiple users, you only have like root and your own user, which whether or not has permissions to access root or not. I mean, basically UID and GID you usually set to 1000. Now otherwise, if you have multiple users, you need to get your UID and GID. You do that by easily typing ID, and you get all the IDs of groups also that you are in. So then next thing is eocarset UTF-8. This basically converts everything to UTF-8 for Linux to read stuff to read stuff normally, so you don't have some kind of weird characters instead of special characters. You set read write option, which is redundant because default does that. Windows names, it's an important one, otherwise Windows will, it's not an issue with NTFS, it's an issue with your other operating system, Windows. Windows will always try to fix the drive if it sees some kind of weird names that are not permitted by Windows, because some names are reserved. Now why that's reserved or something, I don't know, come on. No one knows why it's that hard-coded in. Like, That how it was done and that how it is now. I know some kind of printing folder and stuff is like hard-coded or something. I don't know. Now we have also real time or NOA time. NOA time, these are basically performance tweaks. And real time is basically already set, is redundant most likely. And NOA time is used to not like lock your access times to files. That's how you reduce overhead on your drive. Basically, most likely you can do that to every drive. I know I have them only here set, but I could use that as under my home drive easily, also under my root drive most likely. And then we have 00, which is first 0, I don't know what it is, I never use it. And second is FSTK or something. Yeah. This is basically checker for repairer for partitioning formats or something. It is disabled for NTFS3 because it has a different kind of way of repairing a drive. Not like Windows. Windows does have advantage here, but it does have basic functionality when it comes to repairing. That's why we don't set here, we leave that on 0. Otherwise, if it wouldn't be NTFS, it would be something else and not a root partition, then we will set it as 2 to indicate that it's not a root partition. It is mounted somewhere. So this is it for that video. If you liked it, please like. Otherwise, goodbye.